Welcome to the Hashimoto's Doctor Podcast. You're now part of a growing community of people determined to take their health back through education and self-empowerment. But because of the healthcare system today, we don't have access to the types of healthcare that we want. So we have to do things differently. We've got to do things smarter, and we do that by becoming our own advocates. This podcast will give you the perspective and thoughts of one of the world's leading Hashimoto's doctors. So let's get started. Hi everyone, Dr. Shook here. I hope you're doing well today. In today's podcast, what I want to do is we're going to continue our discussion of why there's so much thyroid dysfunction. Some of our previous podcasts, we've been through some of the major topics. We've talked about stress, we've talked about inflammation, and today I want to talk a little bit about infection. Now, we're going to talk some specifics on or infections that could, and that we think that there is a link to Hashimoto's and even Graves' disease, which are both autoimmune thyroid conditions. But I want to cover really the general concept and how we think chronic infections drive autoimmune processes. So let's go ahead and start first by talking about Hashimoto's and Graves' disease, and let's talk about a study that was done. So there was a study that was conducted, and there were 1,023 people with Hashimoto's and Graves' disease. There were about 650 or so that had Hashimoto's, and about 350 or 400 that had Graves. Now, what they did was the conclusion of the study was that different times of birth. Looking at seasonal times of birth seem to be associated with viral infections and different, specific viral infections that triggered and that were more likely to be an initiating trigger of the thyroid autoimmunity. So it was very interesting whenever I came across this information to see. I'd never seen this study. Now I've seen studies where there's believed to be a connection between Epstein-Barr virus and some other types of infections and thyroid autoimmunity, but I'd never seen one that linked the time of year and tied that to a greater likelihood of viral infection that could be an initiating factor for the thyroid autoimmune process. And so this was a very interesting study that I came across. There are also studies. There's a study specifically on a bacterial infection called Yersinia. Okay, so Yersinia enterocolitica is a bacterial infection. And what they found there is that there's a higher incidence rate of Yersinia infection and antibodies in Graves and Hashimoto's patients than in people that don't have Yersinia. So what they're saying there is that if you have antibodies, if you're showing an immune response to Yersinia enterocolitica, that you're more likely to have Graves and Hashimoto's. So that they believe there to be a connection. So why might this occur? And I'm going to tell you that I think that there are many viruses, many bacterial infections, parasitic infections, and even fungal pathogens, fungal infections that can drive human autoimmunity. Okay, so we just talked about viral infections and the time of year that someone's born, and there being an association there. Also, bacterial infection like Yersinia that have been shown to have, these possible connections to thyroid autoimmunity. Let me explain to you why we believe this occurs. At the core, at the heart of it, it comes down to the body attacks this, a foreign invader, right? A pathogen. We're gonna use the word pathogen to encompass bacteria, viruses, fungi, and parasites. Okay, these are all things that are pathogens, things that we we don't want in our body. So we're going to just use this umbrella term of pathogens. These pathogens, let's just to make it as simple as possible, the pathogens may have proteins that are similar to proteins in your body and tissues in your body. And the reason that's important is because the immune system looks at the protein structure and launches an immune response against the protein structure of these foreign pathogens. So keep this. So let's say it's the Yersinia, right? It's this bacteria that we've already talked about of there being a greater level of antibodies, which are made by your immune system, right? The antibodies are produced by the immune system. Antibodies are kind of like Post-it notes. And what they do is whenever they find something that they're specifically made for, which would, let's say, proteins in the cell wall of Yersinia. So Yersinia is a bacteria. It has a cell wall. When the Yersinia is identified as foreign by the immune system makes antibodies that are specifically designed to stick to Yersinia so that other immune cells can come behind it and destroy it when they see that antibody stuck to it, right? So the immune cells only attack things that those antibodies are stuck to. So what ends up happening is, then we're using Yersinia as an example here. This is going to help you to better understand how these chronic infections drive our autoimmunity, or our body to attack itself. So your immune system recognizes Yersinia as foreign, starts producing antibodies that are specifically made to attach themselves to the Yersinia, and only the Yersinia, right? Because we don't want antibodies attaching to things that we don't want our immune system to destroy. So these are monoclonal. They should only attach themselves to the Yersinia, right? Well, let's say that you have tissues in your body. Let's say it's your TPO, your thyroid peroxidase enzyme, the most common target tissue. It's actually an enzyme inside of the thyroid that's associated with Hashimoto's. Okay, so Hashimoto's thyroiditis. Let's say that your TPO, your thyroid peroxidase, has a very similar protein structure to that of Yersinia. Okay, and let's say it's so similar that the antibody that's made against Yersinia, that's made to stick to Yersinia, can lightly attach to the TPO because it has a similar protein structure, right? It's so similar, the immune system can't really tell them apart, so the antibody lightly attaches itself. Maybe it's not exactly the same, but it's similar enough, okay? So this is really important to understand because this is a process called molecular mimicry. It's one of the leading theories on autoimmune processes and why our immune system attacks our own body tissues, or the tissues of our body. And it's because we think that there's something foreign that our immune system is reacting to that's driving an immune response and the production of antibodies. And those antibodies, they may be able to attach themselves to tissues of our body that look similar to that foreign invader. Okay, so that is called molecular mimicry. The molecule of whatever is being attacked by your immune system, whatever pathogen, right? Whether it be bacteria, virus, fungi, or parasite, has a similar protein structure to the tissues of your body, to one of the tissues of your body. So let's say it's Yersinia, you're attacking Yersinia, and Yersinia looks like your TPO, your thyroid peroxidase in the thyroid, and your immune system makes antibodies that are designed to attach to the Yersinia. But what ends up happening is it doesn't, not only does it attach to the Yersinia, but it also these antibodies lightly attach to the TPO, causing you to lose tolerance to yourself, to become autoimmune, for the immune system to attack you. And so obviously this is a problem, right? We know that this is an issue. And so the question becomes, what drives the autoimmune process could be an infection, could be a pathogen that is chronic, that is long-term, that is not, your immune system's not able to kill. Maybe it's a parasite, maybe it's a viral infection that's recurring, because viruses, you don't get rid of viruses. you suppress them. Your immune system keeps them at bay. And so if that is the case where the virus is reactivating, then you've got to work on looking at the systemic health of the person and how can you support more optimal immune regulatory function, right? So that the immune system can keep this virus at bay so that it doesn't reactivate, causing you to produce a large amount of antibodies that then cross-react with some of your own tissues. So the process of attacking your own tissues, or mistakenly your immune system making antibodies that attach to your own tissues, that's called, that process is cross-reaction, where an antibody made for one thing attaches itself to another. And the reason behind that is because of molecular mimicry, where the pathogen or thing that your immune system is reacting to looks similar to your own tissues, so similar that the antibodies attach themselves to your tissues and the foreign thing, right, like the pathogen. So these infections we know are issues, and I'm going to tell you right now that we do a lot of testing for pathogens. We look for the things that I believe drive this process more than anything are going to be three major categories of immune stimulating categories of things that stimulate the immune system. So foods, are you reacting to partially digested food proteins? So if you're reacting to food protein, you stop eating that food protein so that the immune system can calm down and you can begin to work on regaining tolerance to that food. So you can add that food back in at some point. But so you look at foods. You look at these pathogens, right? All these different types of infections. And we're learning a lot about this right now. In science, there's a lot of research going on that is looking at the immune system and looking at these pathogens to help us determine if a particular pathogen has molecular mimicry to human tissues. Okay, so we're learning a lot more about this, and we're finding that this process of mimicry, where a pathogen or a partially digested food protein may look like our own tissues, we're finding there are a lot more things that mimic our human tissues than we thought. Okay, and that's a problem, obviously, because we've got to be specific about what we're doing here. There's a lot of people with autoimmunity. There's a lot of people that aren't well, and telling them to go on a specialized diet, that may help. That may help, but to be specific, we've got to look at that person. We've got to look at what their immune system is specifically reacting to and remove it. If it's a food, we've got to kill it. If it's a pathogen, we've got to get rid of it. If you're reacting to environmental chemicals, which we know now that the immune system can react to environmental chemicals when they bind to our tissues, they create this new thing in our body called a new antigen that our immune system can react to. We've got to get these chemicals out of our body. We've got to remove the foods that we're reacting to, and we've got to remove the pathogens, the infections. These are all things that we believe drive the immune process. This is what I do in practice. This is probably the heart of what I do, is help people identify these things that are driving the immune system. We do our best to try to remove them from remove them from the body so that you're not exposing the immune system to them and further driving the immune system. And we work to dampen that immune process naturally with the goal of trying to put it into remission. But infections play a big role, right? So let's just sum it up. Infections do what? Infections can stimulate an immune response. Okay, they may cause our immune system to attack our own body because the infections themselves, these pathogens, may have similar protein structures to the proteins throughout our body, like our TPO, for example, the thyroid peroxidase, the most commonly attacked tissue in Hashimoto's thyroiditis. And we know, for example, that Yersinia enterocolitica, which is a bacterial infection, there seems to be a connection there, right? Where people that make antibodies against Yersinia tend to make more antibodies or tend to have autoimmunity to their thyroid, with Hashimoto's and Graves. So we think that there's a mimicking, molecular mimicry, where the pathogen has a protein structure that looks like the protein of our body, and our immune system makes antibodies, which are kind of like Post-it notes that stick themselves and adhere to the foreign thing, like the Yersinia, right? And they do that because when the antibody attaches itself to that foreign thing, like the Yersinia, like the bacteria, then the immune system, that marks it so that the immune cells can come behind and destroy it and kill it, right? Get rid of it. So these antibodies circulate through our bloodstream, and if they come across some of our tissues that have a similar molecular structure to the Yersinia, then they may attach themselves lightly. In this case, maybe that's TPO, maybe that's the thyroid peroxidase. They attach themselves, and once they've attached themselves, they mark the thyroid for those tissues for destruction by immune cells. Okay, now this is where the key thing is here. And then what happens is our immune system now attacks our own tissues. So if we can remove the bacteria, we can remove the pathogen. This same process we believe occurs with foods, food proteins, and with environmental chemicals. So if we can identify the things that the immune system is reacting to, remove them from the body, remove them from the exposure to the immune system, then we can work to calm down the immune response. And we see clinically that significantly has a very positive impact on autoimmunity. Now, those are the key takeaways. Infections, we believe, drive the immune process through molecular mimicry, and it's an important thing that has to be considered. And when you're looking at, why is there so much thyroid dysfunction, and the leading cause of thyroid dysfunction is Hashimoto's, which is an autoimmune process, you have to consider infections, right? You have to understand that, as we understand it today, they are a potential driver of the immune process. And one of the things you've got to do is calm down the immune system by removing the triggers, the drivers. Okay? So anyway, I hope this helps you guys out. I know I've gone a little bit longer on this podcast than I usually do, but I appreciate you guys. And if there's anything we can do for you, please do let us know. I hope you have a wonderful, wonderful day, and I look forward to talking to you soon. Thanks. Thanks so much for listening. We hope you enjoyed hanging out behind the scenes with Dr. Shook. You can also talk with and learn from Dr. Shook through Facebook Live on our Facebook page at the Office of Dr. Brad Shook. Don't forget, you can also get access to our videos, guidebooks, and thyroid programs at www.drbradshook.com. Oh yeah, and don't forget one more thing. We can change the world one person, one family, and one community at a time. Until next time, remember, today is your day, and no one will tell you who you are and what you can be.